All right, hello and welcome. So today we're going to cut right through all the hype you see with AI demos. We're not talking about cool-looking toys. We're talking about the real engineering work. Building those robust, production-grade AI agent systems with Python. The kind of systems that don't just work once, but work reliably, every single time. Okay, let's dive into the engineering side of things.
And look, this isn't just some niche topic we're exploring. As the legendary Andrew Ng says right here, Agentic AI is where everything is headed. It's the bridge from just generating text to actually taking action and creating real business value. For any developer out there, mastering this stuff is absolutely the next big step. So, let's be super clear about our mission today. We are moving way past the hello world of AI agents. The whole point of this is to give you a blueprint, a real plan for building an AI system that's reliable, that's scalable, and that doesn't just fall over the second it hits production. Now, the very first and honestly the most important step, it isn't about code at all. It's about a mindset shift. We have to stop thinking like students or just someone tinkering with a prototype. We've got to start thinking like engineers who are actually responsible for a live, breathing system.
So, just pause for a second and really think about this. If a real company came to you today and said, build us an AI agent, what would your actual plan be? How would you structure it so you can add features later? How do you even validate that it's working right? And how do you make sure it doesn't crumble under pressure? This right here is the core engineering challenge.
Thinking like an engineer for these AI systems really happens in 3 layers. First up, you've got the prototype mindset, where it's all about speed. Just get it working. But then you have to graduate to the production mindset, where reliability is the only thing that matters. And finally, you adopt the scale mindset. That's when you start thinking about the whole system, the costs, the performance, everything.
Okay, time to get a bit more technical. The first huge decision we have to make is choosing our foundation, the agent framework itself. And believe me, this choice is going to shape so much about your system's reliability, its cost, and whether you can even scale it down the road.
And just notice the wording here, right? It's not about which framework is the coolest or the newest. It's a strategic decision. Which framework is actually built to support a production mission, a situation where failure has real serious consequences.
Okay, so let's look at the data here, because this is what really tells the story. We've got the big 3 contenders, LangGraph, CrewAI, and AutoGen. Now look, CrewAI, it's awesome for spinning up a quick prototype. And AutoGen is super flexible if you're doing research, but take a look at that error recovery rate column. LangGraph is sitting at a whopping 96%. The others, they're way down at 72% and 68%. And let me tell you, when you're in production, that 20+ point gap, well, that's the difference between a system that actually works and one that's constantly breaking. And this chart, wow, this really shines a light on the hidden costs. Because of its very chatty, back-and-forth nature, AutoGen averages almost 23 LLM calls just to finish one task. LangGraph, with its structured, almost blueprint-like approach, needs just a little over 4. We're talking about a more than 5 times difference in cost and in speed, baked right into the architecture from the start.
So here's the bottom line. For any serious production-level job, features like state persistence and checkpointing they're not optional. LangGraph builds this right in, which means your agent can literally survive a crash and pick up exactly where it left off. That's not a nice-to-have feature, it's a core requirement for a reliable system. All right, so we've got our framework. Now let's talk about the blueprint. A clean, scalable project structure is honestly your best defense against your system becoming a tangled mess of bugs as it gets bigger.
This right here is a battle-tested way to structure your project. And the key principle is super simple. Separation of concerns. Your API layer is totally separate from your core business logic. Your agent definitions are separate from the tools they use. Why is this so important? Because this modular design means you can upgrade one little piece of the system, say a single tool, without the whole thing coming crashing down. And inside this structure, we're going to lean heavily on specific Python features that are just crucial for reliability. Type hints, for example. They're not just for making code readable, they're data contracts. Pydantic models take that a step further, automatically checking that the data an LLM spits out matches the exact format your tools need. This one thing can just obliterate hallucinations caused by bad data. Then you've got async/await, which is a must-have for any agent calling multiple APIs at once without freezing up. And finally, solid exception handling makes sure that if one tool fails, the whole agent doesn't just die. It can catch that error and figure out what to do next.
Okay, let's talk defense. Building a production system is also about proactively hunting down and neutralizing all the common ways these things fail, the production killers that can take your entire system offline.
You know, one of the biggest mistakes I see is people mixing their prompts right into their application code. This turns every tiny little wording change into a full, risky redeployment. The professional way to do it is to treat your prompts like configuration, as versioned, manageable pieces that you can update completely separately from the code.
So, what are these production killers I'm talking about? Well, here are some of the most dangerous ones. Things like missing timeouts on your API calls, or, and this is a big one, infinite retry loops. And that second one, it's no joke. I mean, there's a story about a company that got hit with a $63,000 cloud bill in just 4 hours, all from a single agent that got stuck in a loop. That's the kind of catastrophic failure an engineering mindset is designed to catch and prevent before it ever happens.
So how do we stop them? With a disciplined, multi-layered testing strategy. You start with simple unit tests for your predictable code, the parts that should work the same way every time. Then you move up to integration tests to make sure entire agent workflows are running correctly. And finally, because agents are, probabilistic, you need LLM evaluation. This is where you test your agent against a golden dataset of inputs and expected outputs to make sure the quality of its answers isn't secretly getting worse as you make changes.
So, once you've adopted this mindset and these practices, you're not just a coder who can get an agent to work once anymore, you're an engineer who can build a truly reliable system. Let's kind of wrap all that up into a new power statement for you.
This is your new power statement. Seriously, this is how you explain your value in a job interview or to your team. It instantly shows you get the difference between a demo and a deployed product. You're talking about schemas, orchestration, and testable design. Those are the pillars of real production engineering.
And this really maps out the whole journey, doesn't it? Beginners are just trying to learn the syntax. Strong engineers, they learn how to build systems. But the elite agentic engineers, they take it to a whole other level. They don't just build systems, they design intelligence that is adaptive, testable, and observable from the very beginning. That is the ultimate goal. So I'm going to leave you with this one final thought. Getting an agent to work on your laptop, that's the easy part. The real question, the engineering question, is this. Is it ready to work for the world? Now you have the blueprint to make damn sure the answer to that question is a confident yes. Thanks for joining me.